Kijken wat deze ook doet. Altijd handig om te weten. The OWASP Netherlands chapter meeting of April 2022. Another virtual meeting. We have plans on going physical again with future meetings, but more on that later on in the breaks between the talks. Today we have 3 different topics, all centered about the appearance of security on the web. But first, some general announcements on OWASP. There is an upcoming global event in June. It was supposed to be held in Dublin, but currently it will be virtual from June the 6th to the 10th. More information can of course be found on owasp.org. If you are interested in that, prior registration is mandatory, unless of course, in contradiction to our meetings, the Netherlands chapter meetings are free to join at any time, though we do appreciate a heads up to know the number of people that are going to attend. We have 3 topics today. The first one is Tom Stok, crawling the Dutch government websites on sub-resource integrity. So Tom, the floor is yours.
Thank you. Good afternoon, everybody. So my name is Tom Stok, and I did this research as part of my master's cybersecurity at the Radboud University under the supervision of Ganesh. And as the title says, it's about measuring the current state of sub-resource integrity protection at Dutch government websites. It's quite a mouthful. So the first question, I'm supposing not everybody knows what sub-resource integrity protection is. But basically, if you visit a website, not all resources are loaded from the initial HTML document that is sent. And all the documents that are loaded after, as images and JavaScript and style sheets, those are sub-resources. Most of the time, those resources come from the exact same server as the original HTML, but also a lot of the time, resources are included from other third-party domains. And sub-resource integrity protection aims to protect the integrity of those resources. And you might ask, why do you use sub-resources? Well, firstly, to load your own JavaScript files, your image files, but also to include common libraries. Common libraries might be jQuery or Perl or stuff like that. And those are usually found at content delivery networks, CDNs. And this is due to the improved speed and decreased bandwidth. Only the biggest problem with including sub-resources like this is that usually the integrity is not protected. So why should we care? That's a good question. And we've got 2 news articles about this. Basically, if you include a resource from another server and you don't protect that integrity, if that external server is hacked, you can be hacked by extent. So in the first article, you see that all Afghanistan government websites are brought down by the single act of hackers accessing their content delivery network. And in the right article, you see that the same has happened in the US Army, that the website was brought down not by hacking into the server of the US Army, but by hacking into the server of a resource that was included on the website of the US Army. So therefore, you're basically outsourcing your security for each external resource you load on your own website. SRI, or sub-resource integrity protection, we'll call it SRI for now on because it's way shorter. At first didn't exist, and it was brought to life mainly because content delivery networks were being hacked and because of the big consequences of those hacks. So CDNs are basically concentrated locations that host a multitude of different websites reference to obtain their versions of jQuery or other libraries, and therefore they are prime targets to attack. For instance, if you hack a jQuery CDN, you can perhaps instantaneously hack the 100,000 websites that reference it. Therefore, the W3C, the organizing body for standards on the internet, they included a new standard, a new part of it, called sub-resource integrity protection. What this basically comes down to, the concept is quite simple, is that for each resource you include on your HTML document, you can include a cryptographic hash, a digest, which is a digest of the resource you are referencing. And this gives you control because that hash is stored in your own code on your own server. So if the resource changes, you can recalculate that hash and see that something has changed, and you can reject the resource. This was introduced for link and script tags, mainly because these are the two biggest tags that are being used for referencing sub-resources. There are more tags that include sub-resources, but those are not used as much and therefore were not included in this standard. And of those two, the script tags are more potent because it's easier to execute actual code. It's also possible to execute code via CSS style sheets, but this is harder and harder to exploit. So I've got another graphic. Here you can see a graphic on how the web page is loaded and how the sub-resources are loaded. So the first step is to fetch the actual web page from your own server, but inside that code, inside the HTML that is returned might be references to other services like script, link, and image tags, and those are then loaded by the browser client side from the other server. And those are the resources that might be compromised. So there is a clear way to prevent the compromise of external sources by including a hash in your own source code. However, the biggest problem with this mechanism is not the way it works, but the fact that it needs to be implemented. I've got three figures here with dates and percentages, and those are the percentages of implementation on how well SRI is implemented throughout the web. So all of these are works that scan the top 100,000 or the top 1 million Alexa domains based on popularity. And they scanned on, is SRI actually used for tags that load external resources? We see in 2016, just when the standard was announced and made official, only 0.18% of the external resource references included sub-resource integrity protection. This was already 0.7% in 2018 and 3.4% in 2020, which means that most of the links that refer to external resources are not checked on integrity, which is a major security hole. So why is it so hard to actually implement this protection? There are actually a few hurdles that you have to take in the sense of which resources you include. You can imagine if the resource you reference from your own code with the hash changes, then that resource will no longer be available. And this can be a big problem if the resource that you're referencing to is updated frequently. This is also often updated by design. For instance, if you include a .latest.min.js as seen in the slide, you expect it to be updated every time there's a new version, which means you have to recompute the hash in your own source code of that resource. And there's also the case that the resource you are referencing might be changing over time based on your user ID or the time or some other kind of dynamic resourcing, which you often see in advertising. So this, apart from overcoming these hurdles, will also, or companies and website owners should also improve their development process by adding another step, which is automatically generating the hashes needed to enforce this integrity protection. It can also be done by hand, but as the numbers will show you later, there are quite a lot of references and the chances of manual mistakes is quite high. So therefore, this would be the best approach. Then the second part of the study, why did we choose Dutch government websites? And we choose this because it's a major factor in the Netherlands, in Holland, because the whole population has to communicate with the government. And in this modern age, it's virtually impossible to circumvent using websites to communicate with Dutch government agencies. For instance, if you want to go to the police, you'll usually have to go through their website. Or if you want to do your taxes, this has to be done through a website. Even logging into each of the Dutch government instances, you have to go through DigiD, which is a system of authenticating you as a Dutch citizen. So these websites are vitally important for the functioning of the society. And it's also recognized by the government itself. So they instantiated a new organizational body that monitors these websites on new standards. However, in their report, they do not monitor the SRI implementations, and therefore we took it upon ourselves to check what the current state of those SRI implementations is at Dutch websites. And the next question you might ask is why now? Why not 2 months earlier or in 5 years? And that is because the move to digitalization is becoming more and faster, especially with Corona, as you can see in the meme in the top right, where everything is being forced to go through the internet, through websites. Apart from that, the Dutch government also aims to move all their bureaucracy digitally to improve its efficiency, but it also means that people have to use it throughout websites and other services. So that leads us to the main research question. What is the current adoption of sub-resource integrity protection at Dutch government websites, as said on the initial slide? To actually find this out, we have 4 steps that are part of our methodology. The first step is to actually obtain which websites belong to the Dutch government and which of those are relevant to scan. Of these relevant websites, we want to know, okay, what pages are there? Because we want to scan each different page of the website. Then the third step is to find out what is the implementation rate of that single page. And we also want to make a distinction between normal, regular pages and sensitive pages, as a compromise in a registration or contact form is probably way worse than one of some information page that does not have interaction with the user. So the first step is getting the pages. At the right side, you'll see the pseudo algorithm we use, but it's basically, it comes down to, we have our initial set of domains and we iterate through those and we follow all the links that are on the initial web page. And we follow all the links that belong to the same domain until a maximum depth of 3 domains. So it means all pages you can access within 3 clicks of the root domain is included in this data set. We also separate sensitive pages from regular pages, and we do this by using a regex that checks on the URL if there are certain words in there. It's kind of a rudimentary check, but it checks, for instance, if there's register in the URL. This means that it's a sensitive page because it will convey passwords, usernames, and personal information. And the same for login pages. After getting the pages, we actually want to analyze and crawl those pages. And for this, we use the DuckDuckGo Tracker Radar collector, which is a collector made by DuckDuckGo, as the name suggests, and it's based on Puppeteer. And Puppeteer is a browser simulation agent. You can spin up a custom browser and automate how the browser would interact with the internet. So it's perfect for creating crawlers. And that is what we did. And Puppeteer leverages the Chrome development protocol, which allows you to interact with websites as if you were using the Chrome development tools you also can access from the browser. And the main benefit of using this approach is that it uses an actual browser. The naive approach of scanning the web pages and getting the SRI data will be to parse the HTML that you receive from the server. However, using this dynamic approach, we can also take into account JavaScript For instance, a lot of one-page websites only load their resources after initial JavaScript is executed. So the main benefits of this dynamic crawling, it's more representative of in the wild websites. People will visit websites through a browser and not some static document they update. It means using an actual browser, we can also scan iframes included in websites. And we can handle JavaScript execution, which is done on most websites nowadays. Another benefit is that we can use a more robust implementation or more robust approach as we try to offload most of the checking and the computation of hashes and checking all those things to the browser itself and rely on the output that the browser gives to actually classify what is happening on that page. And the last and most important part is that we have more information channels, as we can also access network requests. We can parse the DOM tree as if we were doing static analysis, and we have access to browser logs. So for each, these are the three main parts of the crawler, which I will dive into a bit more now. So the first collector that we use is a network request collector, and this is provided by the DuckDuckGo Tracker Radar collector. This is one of the collectors they already produced, and it basically collects all the network traffic when you visit the page. In the screen, you can see an image of the output that it gives. So it gives the basic information, the basic headers and response headers. The second collector is the log collector, and this collects the console logs, which you can also see in your browser. And the reason why we collect these logs is because the Chrome browser will emit errors if SRI is wrongly implemented. There are 6 possible errors that we found in the source code of Chrome as a browser that will be emitted if there's something wrong with the SRI implementation. This can range from the hash not computing with the hash that was provided, so a mismatch, the resource has changed, but it can also mean that there was an algorithm used for hashing that is not supported, or that the hash itself is malformed. So monitoring these browser logs, we can specifically say what went wrong or went right with the SRI implementation. And the added benefit, as mentioned before, is this is exactly the same code and implementation that will be run in the wild if actual people visit these websites. So at the bottom, you can see a picture taken from the Chromium source code with a possible error message where the integrity computation is filled. The final collector that we use is the tag collector. And this is a collector that parses the DOM tree in a single pass and recursively collects all the tags that are either a link tag or a script tag. You can see this in the graphic at the bottom, that we have a link tag that will be collected and a script tag, including all their attributes. This also works for iframes that are embedded on the website, so it will dynamically go through everything, which is not possible with the static analysis. The major downside of this is, or well, one of the downsides is that it is single pass. It will evaluate at the end of loading the web page. So that means that if JavaScript is initially executed, that all those changes will be taken into account, that it will not monitor all the changes. More on that later. So right now, after we are crawling the websites, we've got 3 different streams of information, but they're not connected together at this moment. So we need to match all these logs together. So basically, we do that based oriented from the tags that we found in the DOM tree. So for each tag, we will matching network requests and logs based on the resource URL, because this is unique to the tag. And even if it's not unique, we know that the browser evaluates each unique resource only once. As soon as this is done, we have grouped all the relevant things together. However, it can be the case that the DOM tree parsing did not catch all the script or link tags that were present on the website as it was being loaded. For instance, JavaScript could be executed that inserted a script, ran it, and then deleted the script tag again. However, this is still present in the network requests and the console logs. So in the secondary matching, we also create new tags based on those two information streams. All right. So in the end, after we went through all this trouble, we obtained information about each different script or link tag on a page, part of one of our root domains. And this is the information that we collected. The most important information that we collected is, has integrity been implemented, and has it been implemented correctly? So these are all at the bottom of this JSON object. You see the different cases of it being implemented or not, or being wrongly implemented. And this is what we will do our statistics on. So in the analysis, we only focus ourselves on cross-origin tags. And the reason we do this is because sub-resources that are loaded from the same server that the original document is loaded from are not relevant. As in, if you are able to change those resources, you could also change the original web page. So therefore, the integrity does not have to be checked. And we will also only focus on script tags, because not all link tags need SRI, and it's hard to exploit link tags. And the reason that not all link tags need SRI is because link tags can be a variety of resources. The most important one are style sheets, but you can also have icons, images, and other artifacts that are link tags. So that is the reason we will focus on script tags. Here we have the results in quite a big table. Hopefully it's not too confusing. And we split it into the regular results on the left and the results for the sensitive pages. So in the first row, you can see the amount of domains that are being scanned. The second row highlights how many different pages are being scanned. And the last one, or the third one, highlights how many different tags are scanned over all those pages on those domains. So you can see that we scanned around 1 million different tags that we found. And we also found that only 8.4% of those tags, of those references to external sources, have integrity implemented or SRI implemented. So that's actually quite low, which we expected, but is nonetheless not that promising. The thing that was surprising positively was that all the tags that did use SRI, they had a 100% success rate. So there were no malformed or no malformed integrity implementations or implementations where the hash did not match the resource, which would be an indication that the resource are changing often or that the development process are not correctly in place. We also see that for sensitive pages, there is no big difference in the integrity implementation. It's actually slightly lower than the global percentages, which we think is due to some noise that is always in the data. So it's sad to see that no additional care is taken with sensitive pages, albeit not entirely unexpected. We also have the top 10 resource domains that are being referenced, and these are the domains or the places that the sub-resources are collected from. And the first thing you will notice is, well, what I noticed is the extremely low implementation rates all the way to the right. We see that apart from two, all the requests to the most popular destinations do not implement SRI at all. Oh, my backup is completed as well, which is good to know. And the second thing that is worth noting is that of the top 5, actually the top 6, everything is from Google. So Google is by far the biggest player that Dutch government websites at least reference to for the external resources. And we can see in the second column from the right that around half of the domains that we scan, so around half of the major government websites, reference Google, which makes it also, if Google makes a mistake, then half the Dutch government websites will be hit by that at least. And we can see, yeah. So the one with the highest implementation rate is actually one of Google's websites, gstatic. But apart from that, it's really bad. We also sorted the same list, but then on the domains, the resource domains with the highest SRI implementation rates. And what we see is that most of those are content delivery networks. They were the reason that SRI was actually introduced into the web standard, because they were being hacked quite often. But usually those CDNs will provide links to their own resources on their own website. So they've taken it upon themselves to already include SRI hashes in those HTML tags. And therefore we think that is the reason that they have a really high percentage for this. Yes, what we can also see here is that already, if you look at the bottom row of the table, which is the 10th most popular or the 10th best SRI domain, is that it already has a really low 4.2% implementation of SRI. So it also drops quite quickly. There are only a few parties that are being referenced consistently with integrity protection. We can also specify the results per domain that we scan. So you can see the top 5 is doing quite good. And this is kind of the Hall of Fame. And luckily, Nijmegen is part of there where I'm based. So that is good to know. And we see that they're around the 80% mark. However, if we look a bit down, the 19th and 20th place of the best performing domains of the 466, I believe it was. So the 19th and 20th place is already around 25%. So again, the top group of the best performing domains is doing quite okay, not perfect even, because they're not in 100% or even in the 90%, but also the integrity rates drop really quickly. The bottom 2 are 2 domains I handpicked because I thought those will be interesting. So politie.nl only has a 1.3% integrity implementation, even though they have quite a lot of external resources on quite a lot of different pages, which means they are quite vulnerable to sub-resource attacks. And DigiD, which is one of the websites that you have to go through if you want to log in anywhere on Dutch government websites, also does not implement integrity protection at all. And I really should have turned off my notifications. Sorry about that. Yes, so discussion and conclusion. This work showed that the current implementation or adoption rate of SRI is really low at 8.4%. We also see that sensitive pages receive no special attention in the case of this protection mechanism. And we can assume, or we can see from the data, that the integrity rates are mainly due to CDNs implementing or providing links with integrity protection already baked in, such that the developer does not have to do this manually, which is good on the one hand, but will probably mean, as we can see in the data, that only those links will be protected. So that means the other links that the developer has to type themselves will probably not be protected. And we also know that one compromised party is all it takes to hijack a different website. And I've got, again, I cherry-picked some website, Nijmegen in this case, because I was really interested in my own county. And here we see that in the source code, that integrity is implemented almost everywhere. But we also see at the top script tag that some script is dynamically included without SRI protection, which still means that if that party fails, all the rest of the effort will be for nothing. So it's really a mindset that developers should maintain, that they should really implement this over their whole website and not for a single resources. So this work does have some limitations. For instance, the sensitive page matching was now done with a rudimentary regex. So this could definitely be improved. The reliability of the crawler could also be improved because not all domains were actually being scanned due to CAPTCHA and other measures against bots. And there are no support for CNAME records, which means that if there are domains that are referenced through CNAME records, we do not know their origin, which basically means there's domain obfuscation. So the next steps will be, of course, to fix those issues, but one of our other goals was to have the crawler that we made publicly available so people could easily check their own websites. I think the next talk is from basisbeveiliging.nl, and I've seen their dashboard where you are able to do such things. So perhaps another module could be made where you can plug in your websites and it will give you SRI score. And the improved sensitive page matching could be improved by matching based on content of the website instead of only the URL, or using machine learning or utilizing the browser features, as currently there are browser features that can recognize those pages. All right, that was the presentation. I hope you found it interesting. So if there are any questions, please ask them.
All right, Tom, thank you for your presentation. And indeed, in the YouTube comments, there were...
If there are any, as I do not have the chat open.
Oh, sorry. Yeah, here my sound works again. Well, Tom, thank you for your presentation. There have indeed 2 questions been asked in the chat, but I think, as they were at the start of your presentation, that they have been answered by now. The user, Secure Step 9, wanted to know what tool you were using to obtain your data. And of course, well, you already said so, and that it will be online available, at least that is the intention. So I think that question is answered by that. And the other question was from Hans Spaan, if I'm correct. Yes. How do you handle scalable vector graphics? Because you said we're looking for script tags, but well, SVGs of course can contain script as well.
Okay, yeah. So I think those are included in image tags. I'm not quite sure.
That's correct.
And that was outside the scope of the SRI implementation in general, because SRI can only be applied in its current state to script and link tags, and not to, for instance, image tags or iframes or other sub-resources. So this was a decision made by the W3C to only implement it for the subset of HTML tags. So even if you include SRI and script and link tags, you could still be vulnerable through SVG images, I should say. But that requires the W3C to change things.
Yep. Okay, clear answers. Looking at the comments, there's no further questions at this time. All right. I think that gives us a 5-minute break. So to all viewers or listeners, please grab a drink, and we'll be back in 5 minutes with Elger Jonker on his basisbeveiliging.nl website. Thank you very much. Welcome back everybody to the OWASP Netherlands chapter meeting of April 2022. During our break, another question popped up from Time Master, or Tees Master, I must say. Tom, thank you for the very interesting talk. I'm wondering about how much value does SRE have when you are hosting your assets from your own domain. So in our case, we're running Azure front door in front of our web applications, and that's also a CDN. So would it make sense in that case?
Well, thank you, Master, for the question. It's a really relevant one. I would say it would not be relevant to use SRI for resources that you host on your own server, as if the person or a malicious actor will be able to change that sub-resource that you include, they would also be able to change the source code of the website entirely. So therefore, kind of defeats the purpose. So this is a tool that is mainly or only aimed at including resources of other servers, or the services or other domains of access control. I hope this answers the question.
So basically servers from a different origin.
Yes, exactly. Yeah.
All right. Thanks for the additional information. Our next presentation is from Elger Jonker, the web security map, or also known as basisbeveiliging.nl. Let me enable the screen. Yep, there it goes. Elger, the floor is yours.
Ooh, thanks. I hope this is one of the last online things that are like mandatory because of COVID. Otherwise, it's fine, of course. Because I like to see everybody again. So my name is Elger, and I'm working with a team on web security map, and they also call it basisbeveiliging.nl. This is an implementation of that tool. Web Security Map is an open source tool that you can download and use for free. We also have email support and such if you have questions. And I think you're bound to run into some of them because it's a very complex piece of software. We try to make it simple, but it's still complex. It does a lot, and that's what you will see. On the screen, you see already the logo and some maps. And the product is named after what it is doing. So security on a map, displaying security on a map. And when you do such a thing, organizations change. It has a huge impact when you display how well an organization is doing in terms of security. It instantly gets top of mind. It instantly gets budget, time, funding, the board also suddenly has motivation to do something with security at the level that we can measure and display. So that's a really nice benefit of doing security this way. So we're doing this for a while, and what you can do with Web Security Map is measure security at gigantic organizations, so huge, such as all municipalities of the Netherlands, which looks like a really nice map, or for example, all governments in the world, or all security companies, or schools, or all I don't know, churches, whatever you want. So you can have this huge amount of data that is visible and understandable really simply because it's plotted on a map, just like your atlas is you're used to. So these are some maps from the Netherlands. You see here that there's already a lot of change. And if you go to the website right now, so this is 2019 and 2020, if you go to the website right now, the map is red again. And that's mainly because we keep on adding automatically new subdomains and new scans. And that means that it's harder to become and stay green. There's all kinds of tooling for that. There's all kinds of explanations for how to become and stay green, but organizations still struggle. And mostly that's due to vendors not willing to make a move, and they get a huge amount of pressure. So here you see the Netherlands. A while ago, we also made a map for Dutch governmental organizations, which I will be showing later on again. And we also, for example, did the European CERT organization, the Computer Emergency Response Teams. And you see that also these organizations don't do very well in terms of the basic security things that we measure. I'll show you what we measure in a moment. First, what I said about top of mind, this is what you can see if you look at 2017 to 2020. You see a slow transition from a completely red map, which is if you start this tool in any new country or any new organization, more often than not, everything is red. Maybe some orange, but mostly red. And that is a nice place to start because then you can actually see things becoming green and orange and people becoming happy. First, they might be a bit grumpy because change is hard. But afterwards, they will be happy because they made a change and they made the web better, and they're securing their own customers or their own people a lot better. So all the reason to do good security, of course. What you see here at the bottom of the slide, you see that the 3 big municipalities in the Netherlands had a competition to drive the number of security issues down to 0. This is over the course of a few months, and they all got it. They all sort of got it together, and then many new projects happened and many new stuff was added. So it's still red, but mostly it's green. So that's nice to see. We'll dive into a little bit of detail later on. So what does this measure? It's, of course, will not measure anything that if you display it and if you make it public, it becomes a security hazard. So it only measures things that you can publicly show that are wrong and that are not like a breach or something like that. So it's not, these are all the open databases over here, and here are the SQL injections over there. That would be catastrophe. Yeah, that would be a giant catastrophe. So somebody did that way in the past, and I think that person is still residing in jail or something. It's not a wise decision. It makes everything for the worse. So we have made a selection on what you can measure, and those are things like DNSSEC, and like what Tom showed, sub-resources could be added because they are not dangerous to show. TLS encryption quality, so how well is how strong is your encryption, and also is your certificate still trusted? Like, is it expired, or is it running from the wrong domain, etc. Those are checks done by Qualys. They're using the Qualys API for that, which you can use as long as you publish the results and mention that they're doing that test for you. It also tests website without TLS. It tests FTP and file transfer protocol, which is something that is like old school web, but you will be amazed how many websites still, or how many domains still run file transfer protocols, like in the thousands for the Dutch government. Like, why? But they still do, and probably there's a reason for that. And you can see if they do encryption on FTP. And of course, if you can email with an organization using StarTLS, or that you can encrypt your email data. And you can also check if the organization has all their countermeasure implemented to prevent spoofing, such as the SPF, DKIM, and DMARC records, which I'll also get back to in a moment. And there's also a number of security headers that are being checked, which are not really that severe anymore if they're missing, and we're on the track to phasing them out, except for strict transport security. That's still relevant, but like X-frame options and such, most of them are moved to the CSP header, and yeah, those are defended by the browser by default now. So it's not a lot to do there. So what you can see here on the right side is that just some statistics for the map that we run on basisbeveiliging.nl. It's like 350 municipalities, 12 provinces, and 800 governmental organizations with a total of 32,000 services. So for just 32,000 services, I think we're now in the 50 or 40,000. We check all these things. Well, if they're relevant, of course, if it's an email service or a web service, etc. So once that is checked, it is published. So it's published overnight. Every night a report is made, or whatever, when you want, every hour. You can also set it to every hour, and you get a report that is visible by everybody. And it contains like, you're doing this on your website, like you have these and these headers, and it has a rating. In for example, in this case, everything is perfect and nice. And there's also a second opinion link, so you can click it and you can get an opinion from another service that might give a different opinion, but usually it's the same. And there's also a documentation link, so if you want to know more about this header or this technology. And you also see, of course, the OWASP links to documentations about these headers. And last but not least, there's an option for organizations to explain why their, for example, imperfect stuff is by design, why it should not be secure, for example. And there are situations where you do not want HTTPS or headers set. For example, certificate revocation lists are served over HTTP, and it would be a chicken and an egg problem if you would have HTTPS serving that. So they're served over HTTP, and there's a validation inside the data that you're downloading. So the web is pretty complex. Like if you go to the 10,000s of domains, the web gets a lot more complexer than just websites. There's already there are some reasons why things deviate from the norm, and if you would use any kind of tooling, you would see that it would be wrong. So yeah, there's an explanation option, and we do a lot of explanation automatically. For example, for certain cloud vendors that just do not want to adhere to the standards and have been pressured like for 5 years, and everybody has just given up. And if we would not do the comply or explain there, then the Netherlands would just be red. That's it. But they're not going to buckle. So yeah, we have to let other people still have the option to make things better. Some deployments that we're running now, basisbeveiliging.nl has municipality, has data from the hospitals, has provinces, and has the entire Dutch government. And you can click on each of those maps and zoom in to your local area and see how well things are doing, how well your local hospital is doing, for example. In Bulgaria, the Bulgarian e-government is using Web Security Map for their entire country. It's not a public installation, but it's really nice that they use it. And they also, they automated basically everything that they used to do by hand. So that's nice. And on internet.nl, they have a dashboard that shows that where you can scan like 5,000 domains in one go. And the engine doing that is the Web Security Map engine. So I'll show you, I see the time is running out a little bit, so I'll show you some pages that are on, when you run a Web Security Map, you have also a lot of statistics. These are statistics screen grabbed today, and they might be a bit off, but they're mostly true. And you see that currently, if you look at who is the best and who's the worst, you see that Groningen is currently the worst offender. And there's a big gap between Groningen and Amsterdam, and it's really unlikely that Groningen is doing something wrong. And I think it's a bug or something weird happened, so I have to look into that. On the other side, you see that there's a number of graphs, and these are the vulnerabilities over time. So every metric that is measured is being saved, every change is being saved, so you can get these nice graphs over time from the day we started. So we can go back to 2017 and get a map from an exact date. And it's really nice to show progress or deterioration. So as I said before, the reports in the tool are fully public. You can click on them and see how well everybody is doing. This is a report of Sertogenbos, the municipality where I live, and they're doing pretty well. All the red stuff is gone for a few months now, and they only have one medium risk. And if you scroll down on that page, you can see what this medium risk is. And it's probably not the biggest security issue in the world. Because it's open and transparent, all the data on the website can be used with ease. So it's all JSON calls. So I see people hacking away with getting all the municipalities and all the data on the site in JQ and extract all the data from it, all the domains, and then run it through a script to test other things. I see that, and there have been people doing responsible disclosures just from this data that is exposed via this way. It saves a lot of crawling, and it also makes the web more transparent and easier to use. What Web Security Map can be used for is, for example, security campaigns. And we tend to do such a thing once a year. Last year we had two. There was one on vital organizations by the Dutch investigation journalistic program called Zembla. It's well known in the Netherlands, and if they say something, people listen. And what they said was 43 of the 100 vital infrastructure companies in the Netherlands are insecure. They are vulnerable to email spoofing. And so we measured that, and using that information, there's a report was published, and there was no going around the issue. And well, in a month, like 31 improvements happened, and those are not your mom and pop store. Those are really giant organizations where setting even the most simple header or simple DNS record can cause a lot of pain. So a lot of pressure was exerted from this report. And another one, last year we added all hospitals and GGD, that's a Dutch thing. And we found that 25% of all hospital sites have a vulnerability, and it has been published like everywhere. So we tend to do one such thing every year to gain attention and to show what the tool can do. So yeah, and it moves people, it drives people, drove the hospitals to improve, and that's nice to see. So if you want to do this for yourself, it's 100% open source. You can do that for your own projects. If you have a certain niche or a certain market that you want to see how well they're doing. Of course, you need to get some of the domains and addresses and such, but the tool can import spreadsheets. So you can set up a nice spreadsheet, get it imported, and from there it does geocoding for where the dots are on the map, and then it starts scanning and finding domains for you automatically. So it's really fun. It's mostly Dockerized and such, so it's a pretty modern environment. Could be nicer, of course, but basically, if you have a server like an Ubuntu server, it's basically running 3 or 4 commands, and then your installation is running, and then you could do the application management stuff. So that's web security map. I think I'm within time still. If you want to reach out to me or have any questions after this presentation, you can find me at internetcleanup.foundation. This is the foundation that is behind the source code. That's the owner of the project. The demo of the Netherlands is at basisbeveiliging.nl, and you can find more data and more screenshots on websecuritymap.org. So yeah, I hope that it can be useful for your project and for your market. And let's hope that you can also push the change and make the change and have like thousands and thousands of vulnerabilities being solved in a really short amount of time. We've seen it happen like 4 or 5 times now. So it's basically roll out, communicate, and have fun. And that's it. So I also wanted to tell something else, really short. I'm working really, really hard on the Dutch Hacker Conference this summer. It's called May Contain Hackers. It's in Zeewolde. It's 55 kilometers from Amsterdam. And it has like hundreds and hundreds of talks. A lot of people also from OWASP will be there with the village. So if you want to join the madness, then go to mch2022.org, and you can start your journey into the Dutch hacker camps. It's an enormous event, and it's a lot of fun to work on and to work at. And well, if you want to visit, go to the website, which is circled in red, and join. I think it's one of the most epic events this year in terms of hacking events. There's of course EMF Camp in England, and afterwards we are in July, I think the 22nd to the 26th of July, on a beautiful scouting estate in Zeewolde. So that's a picture that I wanted to make because well, we're working very hard on it, and we want everybody to be there. That's it for me.
All right. Thank you, Elger, for your presentation. And you're indeed well within time. Actually, I think we're running 10 minutes ahead of schedule at the moment. Your talk lasting about 20 out of the 30 that was available. But indeed, May Contain Hackers, sorry. Nice conference. I think the previous one was that Observe Hack Make?
No, that was 2013. SHA, Still Hacking Anyway, was at the same terrain in 2017.
Still Hacking Anyway. Either way, a different name each time. Very good.
It's a hell for marketing.
Yep, that's that part is obvious. So, oh wait, there is actually a question appearing, I think. Secure Step 9 asks, will it work for non-geographic data, such as business units of a large organization?
Yes, it does. But the value of the map or the display would be pretty boring, would be 1 dot. What we see with large companies such as Unilever or name some large company, they tend to have offices all around the globes and business units divided everywhere, and you might play with that a little bit. So, for example, if you know that Unilever in Rotterdam makes washing powder, you can do all the washing powder there, and you can do all the I don't know, but they make basically everything. So I don't know, peanut butter is made in Germany, so you can put that in Germany. So you still have a value from that map and recognize your divisions. What is missing and what could be added is a hierarchy. I think that's really hard to pronounce. I'm sorry. So to have a hierarchy that you can see what organization or what part of the organization is responsible for what. That hierarchy is not present in the software right now. So that visualization is not there. It's only a map because that was the most obvious for governmental organizations.
All right, that's a clear explanation. So if you want to map, map something yourself, actually. I think, it's time for a short break and to prepare for our last speaker of today. And that's, actually, there are two speakers, Dimitar, Yanev, and Andreas Hauke, who are talking about the Security Transformation Program. We'll be back in about 5 minutes, so grab yourself a drink and we'll see you again later. Thank you. Good evening everyone and welcome back to the OWASP Netherlands chapter meeting of April 2022. We are currently starting with our last presentation of today from Andreas and Dimitar, who will be talking about the Security Transformation Program.
Yeah, thanks, and thanks for having us. And it's really a pleasure to be part of that chapter meeting. My name is Andreas Hauke. I'm leading the security in a business unit of SAP called Customer Experience. And yeah, I wanted to share a bit what our challenges are and how we're trying to transform also our area in the right way. Looking forward on common challenges and challenges that you might also experience. And therefore, also later, Dimitar will show a bit how we do that practically. So I will start a bit with the theoretical part, or where we're coming from. And when I started in SAP as a security architect, my role was like, okay, I have to interact with the development and operations teams to look on how we establish security. And looking these 8 years back, there were a lot of things happening also in the industry. We heard terms like the shift left security. So we want to do early on security. We overall in the industry looked on more doing threat modeling at the design time, looking on the security things there. And also when I supported the development and operation, it was always like, okay, how can we better establish the security inside the design, but also in the runtime. And that led always a bit to some conclusions. And if you think of what are the main partners of a security experts, it's the development and operations teams, so the engineering teams, and they get a lot of requirements. So they get requirements coming from the customers. So when you develop a product, a software, we have also luckily a lot of customers that have a lot of demands and ask, okay, I want special features in my product. Then also you come like from a technology side, the CTO, the technology leaders of the company look on, okay, what are the newest technologies want to use? And when you see all these requirements coming to development and operations, that's already a lot, right? And then if you think of, okay, what is the next? How do we secure all that things? And then in a big corporate, you have, for example, a central corporate unit that comes out with clear policies, guidelines, secure coding practices. But for sure, also customers come up and say like, hey, we have some special security needs. We're regulated customers. We're customers in specific countries which have specific laws nowadays, right? If you think about China, cybersecurity law, about different data protection regulations in Europe, but also then in the US. So there are a lot of requirements coming from these areas, but for sure, we're doing also security activities like audits, assessments, or in the previous talks, right? We saw 2 nice tools to assess the security of an organization and the company to see, okay, what's the security status of the web applications, of the overall infrastructure. And that also adds up to requirements for development and operations. But I think if you think about all this, right, so there's a lot of things coming to the plate. So what is now the right thing to do? Is it something that you read, like, for example, security frameworks like the OWASP top 10 best practices, or the NIST cybersecurity framework to say, okay, can I apply now some of the security controls to my environment as a developer or an engineer who does operations? So, and if you look on, there are a lot of questions, not only how to do it, but also what's the right priority. And besides these 2 challenges, what we always see during the course of the years is also like, okay, how to keep all these security status up to date, how to keep this level of security in a continuous way. And if you think about a typical also security control, how it's defined to developers and operations, and I'm just giving here an example of the NIST cybersecurity framework controls, right? So it might be a bit cryptic to somebody who wants to develop a feature or who wants to run a system, right? And that is also always a bit of a challenge that we're seeing is like, okay, from a security side, we're coming up with, for sure, like standards, clear guidance or clear security controls, if I would interpret them, if I read the security continuous monitoring control, or also the detection process and procedures. For me as a security expert, that's clear. I know what's in the NIST SP 853, what's meant with that. But if you think about our partnership to development and operations, sometimes I have the gut feeling we're forgetting that this is not the main business of the people we are working with, right? So how do we translate? How do we help our partners in that partnership to better understand what are the requirements? How do we do that? Who has to do what? And especially in which cadence, or also how we can integrate that during their normal daily work. Because I think with the paradigm of shift left or security not being an afterthought, I think it's for us as security community really the challenge, how do we make it easier to consume for our partners to really apply all the nice things that we invented in the security industry and the security field, right? And this is where we sort of, okay, we share a bit how, we have done it and how we thought about it, but also why we're sharing that. We hope with sharing that in the broader community that we get some ideas from this community, from other communities to improve our methodology, how we really integrate security in a continuous way into the secure development lifecycle, into the operations lifecycle, and the system lifecycle. And the first thing we thought of, okay, how do we translate all these requirements, all these projects coming in, right? And if you think of, there might be like somebody comes from a corporate side saying, oh, NIST cybersecurity framework is something nice to roll out. There's some requirements coming with that. Some other come say, oh, I have a project, I want to migrate a software to another data center. And therefore we have also to meet some security requirements. But often these security requirements are overlapping. We need to have authentication, we need a proper access and authorization concept, right? We need to encrypt all the data using TLS, using then encryption at rest. And sometimes frameworks and projects overlap as well. And this is also something we took into account. How can we better translate for our organization, for our development and operations, the needed things? And therefore, what we thought, okay, we needed this translation layer, and therefore we introduced so-called instructions. If you think about the DevSecOps, there's also sometimes definitions of done that you add to JIRA items. So we said, okay, we need to say what is the baseline level, and that's also coming a bit from the maturity levels from frameworks like CMMI or others. So what is the first level? What is the second level to achieve the third, the fourth, and the fifth, right? So it's a bit of a maturity adoption and a definition. But the most important thing is that we started with the simple thing. We said, okay, we want to have clear instructions, what somebody has to do. We also need to explain what needs to be done in regards of who is doing what. So with a clear responsibility and description, okay, as a developer, I have to do something, as a product team, right? As a security expert, I have to do something. So it's clear who has to do what in that whole sense, and then also how it is executed. What is the first level of the security measure to do? And what you see on the screen, and maybe some of you read that already, it's an example of an instruction that we created for static code analysis, right? So we develop code. So to scan code is a good practice, yeah, or doing a code review. And that's also where we said, okay, the first level, if a new team starts a new development, at least they should start with executing the SAS scans once per release if they're not yet continuously releasing. So that is what we said, okay, here it's a level 1 instruction is we scan the code before the release, yeah, and then also we say, okay, where does it come from? It comes from, yeah, our secure coding practices. It's also in the BSIMM, right? You find it in some controls. So there's already a mapping for the first things. And then, okay, who has to do another things? But is that enough? Is that the best maturity level you can think of? No, I think everyone agrees there could be more, like, for example, that the code scans are really adjusted, that you know what to do, that it's adjusted to the libraries you're using so that you have a relevant configuration set, and so on. And then we go ahead and say, okay, we want to ship continuously. So that also means we need to regularly execute the code scans, right? To ship a secure code, which then also should be part of the pipeline, right? And this is how we build up step by step an instruction, also how a development team, if they start a new project, for example, get step by step more and more mature from a security level. And the beauty of this instruction is also we put it on Git, in an internal Git for us. So also development and operations can make pull requests asking for improvements. So we create really a partnership with helping, on one hand, operations and development to understand what they have to do in regards to security. On the other hand, we get a feedback channel as well directly to our translation layer, to our policy requirements set that we're having as big corporate. And then looking on, for sure, after, I would say, an adequate level of maturity, how can we even improve with having breaking pipelines when there are some issues, or having more and more automation? So we always looked at, okay, how can we also extend it? Not saying, okay, we end up in the middle, but we have different maturity levels to achieve that. So this is one learning that we had when we look on, okay, why maybe some development operations team had really challenges to apply the security measures, because the understanding was not crystal clear to, okay, what does security want from me? What do I have to do as a developer or as an engineer who does operations, right? And that was one of our learnings and the first part of our method, where we said, okay, we need to define what's good enough, what is the different adequate levels at one point. And then looking also on, okay, how do we regularly assess ourselves and then see how we improve overall? And that is a bit of a more challenge. And I would just try a bit to give an analogy, or things like what my experience was when I worked with development operations team. If you're as a security expert always around and work with them, and they feel like, okay, there's somebody giving them the helping hand, right? That was always a great experience. The developers love to start thinking of how to break a system, how to even look for 0 days in the code. So there was always an enthusiasm. So, but then you went to another team and worked with another team. And then you wonder with the previous team, oh, the enthusiasm for security went a bit away, right? So they went back to pressure on features, functions. And I always wondered, like, okay, how can we get that a bit more stringent? And what I would compare it is really if you train for a marathon, right? You start, you train, you have maybe an individual coach that explains you how to run the marathon, and you run the marathon, then you're happy, and then you go back to your couch, yeah? And then you need another motivation, or at least yourself, like being transparent and motivated, right? And that's always for me also one challenge that we in security face, that, okay, how can we continuously work also with our development operations colleagues to work hand in hand. And what I'm always saying, we're sitting together in a rowing boat. This is why we said, okay, we need this kind of process. And Dimitar and myself had a lot of philosophic discussion. How can we include these things, and also in the agile world and in Scrum methodologies and all that? And if you think of, you have to measure yourself, right? So it's like we saw, okay, you have a definition, what's good enough. So you measure in a continuous base. So you do an exploration, or, okay, what's the security maturity of my organization? Because not everything is technical. You have processes, you have measures that are non-technical. So you check these things as well. You check your technical exploration. So yeah, and we saw some tools before in the talks, right? So what is my security status of my infrastructure? What's my security status of my web application? Yeah, and therefore you have multiple methodologies also with threat modeling, with tooling around, and with that, you know what's your security status and what's your potential gaps. And then if you think about our sport examples, is like, okay, if I'm back from my couch, do I start immediately to run 42 kilometers? I think that's ambitious, but afterwards, if I would try, I would have a lot of pain in my muscles. So you have to think of, okay, what is the thing you can give to development and operations so that they can execute aside their normal tasks of developing features and also operating systems. Yeah. So, and this is where we came to 3 kind of items. So we said, okay, if you plan the capacity for security, you should plan, first of all, what is the uplift for security? So this is what we call an uplift security package. So that's a fitness program to get to the next level. So if we see gaps, we take these, align and saying, okay, that should be like the next package. So we look on how do we get, for example, from level 1 to level 2 and put that to a security uplift package. But on the other hand, you have also to have capacity for the security maintenance. You want to run your static code scans. You want to do your vulnerability patching as an operations team. So you have continuous tasks that you also have to foresee that your partners have to execute. And for sure, there could be some incidents. So that is what we call the third part. It's ad hoc tasks. So if there's a security incident, something unforeseen comes to the desk, like we experienced that all with Log4j or Spring4Shell, right? So there might be things that coming, unexpected. And this is something that we then call, that's a security package for an execution. And then the next part is the essential part out of our methodology. You go and take that security package as a security expert to the planning of the development and operations team. Because I think the learning of the past is, if you're not part of the roadmap, if you're not part of the planning of a development and operations team, as a security expert, as a security enthusiast, you have really a hard time to push then the security requirements, the security package through. And this is what we do then really in the common plan and with development and operations. So we're part then of the planning cycles of the development teams. And then we start executing, and that is also aligned with the rest of the capacity, the rest of the feature development. And then we get that executed, and we're looking on, okay, how did that went? We are also checking, okay, what is the optimization? And for sure, if we identify optimization, we might go and do some security improvements, look on, okay, maybe the security methodology, the security tools need some adjustments, or we even go for an innovation. And the colleagues that showed the two talks before, that are things that we also then consider as an innovation, saying, oh, we take a nice topic, maybe include it as well into our life cycle. And for sure, the whole thing is not one time, it's a continuous cycle. So we're looking on, okay, if the security fitness package was implemented, right? What is the next package? How can we get to the next layer and the next level? And this is, on a PowerPoint slide, nice. But on the other hand, it's also a challenge. And this is also why we said, okay, for the whole methodology, for the transparency, we need a bit of tool support, a tool orchestration. And that is something that Dimitar will demo now and present to all of you. Also with the background that we're searching for feedback, looking on, like maybe we get some partners to develop that methodology and tooling forward, or even then open source it fully. So Dimitar, with that, I hand it over to you. I guess you're muted.
Okay, so first, thanks for Andreas for the introduction round and for giving me the opportunity to present how actually we live this methodology with these ideas fueled by tool support, which is for me extremely important, because as I like to say, like if somebody gives me 10 Excel files to fill in, I really get crazy and start coding some stuff. I'm pretty sure a lot of the people in this call and in development overall feel the same. So what we decided is, we said, okay, let's build a tool that would allow us at least to first understand what is the maturity of the different frameworks and projects that we need to comply to, a tool that would give the people that execute security clear guidance what needs to be done depending to which projects / frameworks they need to apply to. And this is what we are trying to, this is what I would demo today. So the first thing I want to say, as you can see by the URL, by the name, all the data that you see here has been anonymized. It is also like a lot of fake data. So it's just a version of our tool that is intended to do demos. So on the left side, you would see the organization. Typically, that would be your whole organization, split it into business areas, into products, into components. For the demo purposes, you're seeing on the left side the whole world, and then the world is split into countries, and then we have towns inside those countries. So again, what you're seeing here is completely a made-up data, but the idea behind this demo is to show you, to demo what are the capabilities of this tool, and also how we are living this methodology supported by the tool, and get your feedback for it, of course. So on the left side, you have like an aggregation of your whole organization. And here you have the different frameworks that you want to monitor, you want to track in your organization. So it can be the cookbook that we have developed. What you can think about the cookbook is like every process step that operations development, security experts, COO office needs to execute to ensure that we are living secure and secure processes. And then what we do is we map these process steps to different either frameworks. As you can see here, NIST, we have added for the demo purposes NIST, because hopefully it rings a bell with everybody. But also what you could do is you can use the same technology or the same methodology that you're breaking down process steps into expected deliverables of projects that you run, either to uplift security or to introduce new security features across the whole organization. So what we are doing here is extremely simple. Like we have this mapping where the instruction that Andreas was talking, and I'll talk in more details in a couple of minutes, is the common denominator. And the CX cookbook would have all the instructions that are process steps, all right? And then we have the mapping to these capabilities. And then what you can do in the tool itself is like, okay, you can see what is the status of the world, and you can track what is your compliance rate for NIST, for common capabilities. You can see for NIST, okay, I have 0.48 for, I think that was recover, all the functions of the NIST, so detect, etc. And then I can drill down, I can just quickly calculate what is my status, what is my compliance status, what is my current status for the Brazil area. And then I can dig deeper and go to Sao Paulo. And then I can see, okay, for Sao Paulo, in our own cookbook, we have the completion rate of, secure operations, we have the completion rates of response and other functions. So this gives me the overview, but what I need to do if I want to improve, if I want to plan what needs to be better for the next sprint, for the next release, is I sit together with the operations management, with the development management, and then I go and say, okay, let's look at the actual data inside the past, inside the Sao Paulo project, yeah, inside the Sao Paulo state. And then by default, you see, okay, these are all the instructions that we have for as process steps. So you can see there by default managed as, and organized by organization, secure design and architecture, secure operation, and secure coding and implementation. And I can do self-assessment. For the pure time saving, I will not go through all the instructions because we have more than 150 clear instructions to developers what needs to be done. And also for the sake of the demo, because some of the instructions are containing sensitive data, I would share the most simple ones. But the idea is that behind every instruction, we say, what is the process step? And in very much details that I will not show here for that particular instruction, what is the process steps that I need to take? How can I actually execute? How can I leave that instruction so I can fulfill it? Then you see, okay, for which frameworks it is applicable. So in that case, this one is applicable for almost every framework, as you can see it, and you can maintain status whether something is compliant or not compliant. So let me start with something simple. I go to the planning, and then inside the planning, I see, okay, these are the instructions that I have already done. And this is something I want to be doing. And then I'll just add a comment. We start sending the email every 2 weeks, beginning of Q2. So this comment is already preserved. I know this instruction would go into my uplift, and I know that once I'm completed with that instruction, all the framework for the cookbook would be completed, which is great, yeah. But also what is even better is I can switch the view and I can check, okay, what is my NIST status? And where the magic happens is that all these instructions are interconnected. So if you complete one instructions in the cookbook, in NIST, in the project, and this is the same instruction that we have mapped for the other frameworks, then the process, then the status is copied, and then you see always a fresh status, like, okay, so you don't need to maintain 10 different frameworks in 10 different Excels. You have one place. You go, you say, okay, I want for this project that is Sao Paulo, NIST is explicit, is super important for me. I'm going to do the same exercise for the NIST. I'm going to check, okay, what I'm going to execute on, when. So I really create my uplift plan inside the passport. And then if I do it for NIST, then for every other project that comes, for every other frameworks that come, we already calculate all your self-assessment, and then you need only to do the delta. So what you can also do is you can manage evidences, for example. So if you have completed something, I'll just put this into completed, and then you see the graph is moving live. What you can also do is you can manage evidences. So in case you go into audit phase or something like that, you can pull immediately the respective evidence. So it's just like demo evidence, the description, I'll just put this blah, blah. I can put an URL or a link to a share or a link to an output of a file. And then I can say, share the evidence with the line of business. So basically, if this is an evidence that is organizational, everybody can reuse it. And by default, I can also say everybody that needs to comply to the following instruction in my complete line of business is getting that evidence. So then I'm adding the selected evidence. Once I go into an audit phase, I can come always here and say, hey, what's the control? What is the process step? What is the evidence? And then it's inside the instruction itself, we always describe, okay, what is the instruction, how to execute it, what are the compliant frameworks, and what is the expected evidence. That kind of prepares you. So I can do instructions for, I can just Google for, not Google, but like I can just search inside the tool for instructions like I want to maintain architecture. So I see this is not compliant. So here is a better description that I can share with you. What is expected for you to go to execute and then compliant to this instruction. So this is in the cookbook. If I set it to compliant, it would be copied to every single framework as well. And what you can do is also you can just check, okay, I don't care about maturity level 4 and 5, which is really automated. My goal is to get to level 3. I'm also filtering on the instruction for level 3. What we have also developed is something that we call security mandates. So these are instructions that are extremely, extremely important for your own organization and you want to track. Okay, I definitely want to roll out an instruction explaining what is my security policy. And again, I'll not show the security policy, but if you click here, there will be the full-blown instruction. What is a security policy, how long it should be for the different users, for everything else around password management. And then you can say, okay, for my product that is in Montreal, I have a password that is, I don't know, CICD password, and it has administrative privileges that is not compliant. And I'm planning to do the compliance in June. So what we can do is, and then you can see this is already saved. You can say who is responsible for it, etc., etc., which is really cool because now I can know, okay, where I have in my products and in my area compliant passwords, where the development or the operations needs to change the passwords to comply to the passport. I have the uplift plan by when these passwords would be applied, so I can monitor that. And in case something does not happen as planned, we can also upload risks into a risk register that is part of the whole tool, and we can recalculate automatically, okay, based on the number of passwords, based on the number of vulnerabilities, what are the accumulated risks for the world, for the areas, or for the different cities. And I can see, oh, in Montreal, we have a lot of risks. So let me just go to Montreal, and then you can maintain all the risks. As you can see, it's just gibberish with some names, but the tool itself allows you to either create risk, give it a name, a response owner, organization, mapping as well to NIST, etc. And in a nutshell, you also have this kind of one place where you can go and oversee what is your risk, what's your vulnerabilities, what's your maturity status. And then we were thinking about quite a lot. If we have already a lot of information via our security instructions, like how do we do encryption? What is our security architecture document looking like, as I have already showed you? What is our compliance state with certain instructions that we want, especially in the area of passwords? What is our user access management? Yeah. Then what we figured out, and this is what Andreas was also speaking, is like, how can we ensure these things are lived, these things are maintained, and the only thing that we are coming up to a place is like create an environment that is the go-to place for people to get information and to put information. And if you have all these pieces that I was telling, then what you can do as well is you can maintain your security architecture document in a quite automated way by extracting information from those instructions, putting into the architecture document. And here you only see, of course, a plain template that say, okay, these are my user groups, data classification. You have the description of data, and this information can be extracted, of course, from our compliance status inside our instructions. Yeah. Maintained here, or vice versa. If you maintain here, the instructions also can be updated automatically. So you can imagine, of course, what the next steps would be. So if you have a risk register, if you have your automated, if you have risk register, if you have architecture documents, then a questionnaire on top of it, a very natural next step is to integrate threat modeling here, because if we can start in the beginning with the threat model, we can always see what are the existing risks. We can update, if necessary, the architecture document, which is also really, really useful to keep it as a lived document. This is what I always refer to. And if you identify risks during threat modeling, you can automatically push them to your risk register. So it's basically trying to build like end-to-end processes, because very often, due to different reasons, let's call it, like processes stop somewhere where there is a logical continuity of the process. And what we're trying to build here is like these end-to-end processes that are lived, that have well-defined interfaces between each other, that talk through a programmatic language. And with that, I would just stop, pause, and would like to thank everybody for listening. And I'll open if there are any questions.
All right, thank you, Dimitar and Andreas, for this presentation. I think that concludes our meeting. And looking at the YouTube comments, we don't have any current questions. If anybody does have such a question, please put them in the comment. We'll be available for a couple of more minutes. And otherwise, you can always put your questions in the email for us to answer, and I can relay them to our speakers. The recordings of these presentations will be provided online in a short time. And I would like to remind you all that there's an upcoming global AppSec event, which is also virtual. It's on June 10 to 16, if I'm not mistaken. June 6 to 10, not 10 to 16, so June 6 to June 10. Virtual register information can be found on OWASP.org. We have another chapter meeting coming up in May, and that one will be just like this one, on the third Thursday of the month. And I've got to look it up. So the 19th of May, there will be another OWASP Netherlands presentation. Please subscribe to our mailing list or follow us on Twitter for more information. Of course, the chapter mailing list of the chapter information can be found on www.owasp.org/www-chapter-Netherlands, or just search for OWASP Netherlands chapter. Thank you very much for listening. I see that there are no more comments incoming, or at least no more questions. So, oh wait, there is one. That's just thank yous from Hans Paas and Patrick van Rijssen. So, to each and all of you, thank you for the presentations, also on behalf of Hans Paas and Patrick van Rijssen. I see that we have no more questions left here in the comments, so I would like to thank you all, and this concludes our presentation for today.